Hi class, we're either doing this from home as homework or I'm going to be out on Friday, I don't know yet, and this has turned into a classroom assignment. We're just going to kind of have to see how it pans out. If you're doing this for homework, then just do what you normally do. Play through the video, copy down the slides, and we'll talk about it in class on Friday. And if this ends up being sub work, then what I will have done is sent a copy of the PowerPoint to the class through Google Classroom. So I'm asking if it's sub work that a student sign into Google Classroom on the desktop computer. And as we go through the slides like this, if you pull up a copy of the PowerPoint, you should be able to click on the links and play the videos that I have embedded the links for. We're going to proceed either way. I want you to copy these down, and then we will discuss bits and pieces one way or the other. First thing that we have here is about solvents and solutes. I'm asking that you watch the TED Ed video if I'm not here. A solution is when you have one thing dissolved in something else. It doesn't have to be a liquid. That's a common misconception. You can have gaseous solutions like air, or you could have solid solutions like stainless steel. We've called them alloys. A solution is just a mixture of two things together. It's aqueous if you have something that is dissolved in water. That's one of the most common things, and that's why most people think of solutions as liquids. The solvent and the solute are the two parts of the solution. The solvent is doing the dissolving, and the solute is being dissolved. Solutions, you need to know, are homogeneous. That means that you cannot tell the parts apart. They all look the same. They don't settle out. The pieces of them, the solute is so fine that they'll just stay permanently mixed into the rest of the solution. And they will usually pass through a filter without being separated. It doesn't mean that you absolutely cannot filter them out, but it's going to be really hard to do. Substances that usually dissolve in water, you should know, are usually ionic compounds and polar substances. And we're going to talk about water in just a little bit, and we'll explore those reasonings in more depth. All right, if you're doing this for sub work, please have somebody switch over to a copy of the PowerPoint, and you can play Tyler DeWitt's video. And I may show this to you in class because it's pretty cool. About the solution process, what this is explaining how dissolving happens. And the fancy word for that is solvation. Solvation just means the process of dissolving. What happens in solvation is you have the solvent molecules surround the solute, and they begin to drag them out into solution. I'll show you an animation of this, Tyler DeWitt's video, either one way or the other. And basically, you just end up with the ions being pulled into the solution. Some things are more easily attracted to each other. The common rule of thumb is that like dissolves like. So polar substances will dissolve polar things, and nonpolar substances will dissolve nonpolar things. If you try to put a polar with a nonpolar, you're not going to end up with dissolving taking place because they cannot be easily separated and they won't dissolve. All right, the next thing here is about electrolytes and non-electrolytes. We have actually heard these terms before when we've talked about ionic compounds. If you are doing this in class, then please stop and go over to the PowerPoint and watch the Mr. Wizard potato clock video. Mr. Wizard's a throwback to my childhood, so try not to make too much fun of it, okay? An electrolyte, you should already know, is something that will conduct electricity whenever it's dissolved in water or when it's molten, which means it's like a liquid at really, really high temperatures. All ionic compounds are electrolytes because they will break up into ions. They'll break up into positives and negatives, and that helps transfer electricity. A strong electrolyte is where something basically completely separates into ions or almost completely separates into ions. Those are really, really good conductors of electricity. A weak electrolyte is whenever you have something that dissociates or breaks apart just a little bit, so it'll conduct electricity a little, but not a whole lot. A non-electrolyte doesn't separate at all because it doesn't dissociate into ions, and so if you just had pure water, like nothing in it, it was completely pure, then it should be a non-electrolyte. But most of the water that you come into contact with is an electrolyte because it's got stuff dissolved in it, a little bit of salt, it's got minerals, so it's kind of hard to come across things with water that aren't electrolytes. And then you have hydrates. A hydrate, you know, if you're familiar with the word, with the prefix for the hyd part of it, like hydration, dehydrate, it refers to water. A hydrate is something that contains water on it. You write it with a dot that connects the formula and the water molecules. I think we may have looked at one of these in class before, and I'm kind of surprised I don't have an example up here, but it'd be something we have to come back and get in class. Or you can get it through Mark Rosengarten's video in just a second. If it's not a hydrate, it's called anhydrous. So the opposite of a hydrate is anhydrous. Some hydrates will actually change color whenever they're wet, and that's a use of them, is that they can be used to tell you if water is present. Then here's some really weird words that go with hydrates. Something is considered to be efflorescent if it gains or loses water very easily. It's hygroscopic if it absorbs moisture easily, like a desiccator. They have these things that you find in pocketbooks and book bags, these little packets that are like silica gel that say do not eat. It's a really bad idea. And what they do is they absorb water and they keep the product from getting like moldy and mildewed. And then you have deliquescent. And I have a video that I can show you of these once we're in class, where some things are actually so water-loving that they will basically dissolve themselves. They'll absorb so much water that they go ahead and turn into a solution. And it's kind of neat to watch them do it. One of the things that we're also going to look at is the percent of water in a hydrate, figuring out what percentage of a hydrate is water and what percentage is the other substance. So if I'm not here, I'm asking that you go watch Mark Rosengarten's video, have somebody pull up the actual PowerPoint and click on this link and watch his video, and then I have some practice problems that hopefully I've remembered to leave with you. If I'm in class, then I'll do them with you then. Stay tuned for the next video.